Good morning. This is Dr. Geeta Vani. In the previous session, we have discussed about the basics of push-down automata and seen how to design a PDA for the given context-free language. Now, in this session, we will discuss about the equivalence of PDA accepting the language as N of M and as L of M. So already we know that the push-down automata can accept a language either by going to the final state or by emptying the stack. Two ways are there. If it accepts the language by going to the final state means we will represent it as L of M. If it accepts the language by emptying the stack means we will represent that PDA as N of M. Now, in this session, we will see their equivalence. Both are equivalent. We can construct the PDA for the given language either by going to the final state or by emptying the stack. First, let us see if the PDA accepting the given language by going to the final state is given, how to construct the equivalent PDA which accepts the same language by emptying the stack. That is, L of M is given. Then we have to construct the N of M for the given language L. So let M2 is the mission. M2 is the mission which accepts the language by emptying the stack, and let its description is like this: Q, sigma, tau, delta, Q naught, Z naught, F. This is the PDA accepting the L as L of M. Then from this, we can construct an equivalent PDA which accepts the same language L by emptying the stack. Let us see the construction steps. M1 is equal to Q union QE, Q naught prime. Next component is sigma. Next, tau union X naught, delta prime, Q naught prime, X naught, pi. I will write the M2 description also here for your recollection. M2 is equal to Q sigma tau delta Q naught Z naught F. This is the given PDA accepting as L of M. Now in the M1, that means in the PDA accepting the same L by emptying the stack, the set of states is nothing but the Q, the set of states present in the M2 mission union. Two new states are added, QE and Q naught prime. And here we are taking the Q naught prime as the initial state. Next, the second component is sigma. Sigma is the same. The input alphabet is same for the two missions. Tau for the M1 will be tau union X naught. And delta prime, I will tell the rules. Q naught prime is the initial state and we are adding a new stack symbol X naught and we are making it as the initial stack symbol. Pi is the last component is pi. That means we are accepting the language by emptying the stack. Now we will write the delta rules like this. Delta prime is equal to delta prime of Q naught prime epsilon X naught is equal to Q naught Z naught X naught. That means being in the initial state Q naught prime and without reading any input symbol and by taking the initial stack symbol X naught, we are going to the Q naught, which is the initial state of the M2 mission, and we are adding Z naught to the stack. We are making the Z naught as the initial topmost stack symbol now. This is the first rule. Now second rule, delta prime of Q A Z is equal to delta of Q, A, Z. For all Q in Q, Z in tau, and A belongs to sigma. That means whatever the transitions that are happening in the M2 mission, same transitions will be followed by the M1 mission also. So by following such transitions, finally the M1 will lead to the final state. So third rule is delta prime of Q epsilon Z is equal to QE epsilon. So without reading any input symbol and whatever be the stack symbols that are present in the stack and being in the one of the final state, this transition is leading to the QE state and making the stack as empty by erasing the Z symbol. So finally we are accepting the given input string by emptying the stack. So this is the way in which the equivalent M1 can be constructed from the M2 mission. I will explain these three rules again. See, delta prime. First rule is delta prime of Q naught prime epsilon x naught is equal to Q naught Z naught x naught. Here Q naught prime is the initial state of the M1, and without reading any input symbol, by taking the initial stack symbol, that is x naught, we are going to the Q naught state and adding the Z naught to the stack. That means we are entering into the initial configuration of the M2 mission. Now being in the initial configuration of the M2, whatever be the transitions that are happening in the M2, same transitions will be followed by the M1 mission also. So delta prime of QAZ is equal to delta of QAZ. By following these transitions, finally the mission will enter into the final state by processing all the input symbols. Now third rule, delta prime of Q epsilon Z is equal to QE epsilon. So now we are in the final state. There is no input symbol to read. So without taking any input symbol, that is on epsilon, and by considering the stack symbols, we will go to the QE state and we will erase that stack symbol. So this third transition rule will be applied repetitively in order to erase the entire content of the stack and in order to make it empty. So we will finally land in the QE state and the status of the stack is empty and we are accepting the given input string. So both M1 and M2 missions are equivalent. Now let us see the reverse of this one. Suppose if M2 mission is given, that means the language is accepted by a PDA which is accepting it by emptying the stack, that means as n of m. If this mission is given, how to construct the equivalent PDA which is accepting the same language by going to the final state as L of m. So let M1 be the given mission. Let M1 is equal to Q sigma tau delta Q naught Z naught pi. Let this is the PDA which is accepting the language as n of m, that is by emptying the stack. This mission is given to us. Now from this we can construct the equivalent PDA M2 which will accept the same language by going to the final state as follows. Let M2 is equal to Q union Q naught prime comma QF. That means we are adding two more new states to the original Q. Q naught prime and QF will be added to the given Q. Next sigma will be same, input alphabet will be same. Next tau, to the original tau we are adding one more stack symbol known as the x naught. So here tau in the M2 mission is nothing but original tau union x naught. Next delta prime, the initial state for this mission is Q naught prime and initial stack symbol is x naught, and there will be a final state known as the QF. This is the set of the final states. So the 7 tuples of the M2 mission is Q union Q naught prime QF, sigma is same, tau is the given tau plus X naught symbol, delta prime, I will tell the delta transition rules, and Q naught prime is made as the new initial state, X naught is made as the stack symbol, initial stack symbol, and QF is the set of final states. Now delta prime is defined like this. First rule, delta prime of Q naught prime epsilon X naught is equal to Q naught Z naught X naught. So we will be in the initial state Q naught prime and initial stack symbol is X naught without reading any input symbol. That means we are taking a epsilon move here. We are entering into the initial state of the M1 mission and we are adding the Z naught, that is initial stack symbol of the M1 mission. Means it is nothing but the initial ID for the given M1. Next, second rule, delta prime of Q A Z is equal to delta of Q A Z for all Q in Q, A in the epsilon union sigma and Z in tau. That means whatever be the transitions that are happening in the M1, same transitions will be followed by the M2 mission. So if M1 accepts a particular string, M2 will accept the same string. So how we will accept means the third rule, delta prime of Q epsilon X naught is equal to QF epsilon. So after the entire input string is processed by applying the second transition rule repetitively, finally we will empty the stack and the string is accepted according to the M1 mission. Now in the M2 mission there will be additional transition rule, that is delta prime of that particular Q where we have landed and without reading any input symbol, that is there is no other input symbol also, and by considering the stack symbol X naught we will go to the final state QF and we will keep epsilon here, we will erase it. So finally we are going to the QF. So both M1 and M2 missions are equivalent, they are accepting the same language. So finally we can conclude that if a context-free language is given, we can construct the push-down automata either by accepting the language by going to the final states or by accepting the language by emptying the stack. In any manner we can construct the PDA. If one particular PDA is constructed, then we can construct the equivalent PDA in the different style. So we have shown the steps of construction if M1 is given, how to construct the M2. So with this session is closed. Thank you.